This is Richard Hollingham for ESA at the Royal Observatory of Belgium in Brussels.
For more than a century, scientists have been making observations on this site using telescopes like this, still in use today. In fact, this is the World Data Centre for the Sunspot Index. Now though, Solar Orbiter is giving us a whole new perspective of our nearest star.
Solar Orbiter was launched from Cape Canaveral, Florida in February 2020. The spacecraft has since travelled some 2.5 billion kilometres, made 2 passes of Venus to get a better view of the Sun's poles, and 1 pass of the Earth. Now it's just made its first close approach to the Sun, taking it within the orbit of Mercury. During temperatures of some 500 degrees Celsius, the pictures Solar Orbiter's returning show this atomic furnace in unprecedented detail.
I was personally blown away by the quality and degree of detail in these images. And clearly, as solar physicists, we've been looking at images of the Sun for many years. But by going 3 times closer, we can get the spatial resolution up by a factor of 3. And we see things that we haven't seen before. And that's, of course, the beauty of science, to explore the unexplored.
These new images were captured by a camera called the Extreme Ultraviolet Imager, led by the team based here in Brussels.
It sometimes happens, I get into my office, I download the latest data and I stare for hours at it. It's so addictive, actually.
The images show activity in the outer layers of the solar atmosphere and reveal a variety of features, including something scientists are nicknaming the hedgehog. It has a multitude of spikes of hot gas reaching out in all directions.
Nobody has ever seen the details of the corona in that much detail before. So every time we get an image down, it's the first time we see something at that scale, and that's really fascinating. It's really discovery space that we're entering.
The Extreme Ultraviolet Imager is one of 10 science instruments on Solar Orbiter, now all working together for the first time. Some are looking at the Sun, others are measuring the environment around the spacecraft. All this activity is being coordinated at the European Space Astronomy Centre in Madrid.
It's important to have all the instruments working and operating in a coordinated way, because one of the main goals of the mission is to link the Sun and its activity with the environment, and not only the environment close by, but also the planets. And for that we want to look at the Sun's activity, at the solar activity, with many different telescopes that look at it in different wavelengths. So that means they are looking at different layers in the atmosphere, and they can also measure things like the magnetic fields on the Sun.
The influence of solar activity, particularly on the Earth, is known as space weather. It includes the effects of the stream of charged particles the Sun emits, the solar wind, and more dramatic events such as solar flares.
Yes.
So do you think that would be a good target for Solar Orbiter to point at, this active region?
As it happens, Solar Orbiter observed several flares and even a coronal mass ejection, all tracked from here in Belgium at ESA's Space Weather Coordination Centre.
Solar Orbiter is basically a research mission, but ultimately we want to be able to predict space weather. These are energetic events that could have an impact on high-tech installations on Earth, GPS satellites, power grids. And we want to make sure that in the future we can predict geomagnetic storms based on solar activity. And for that we really need to take the Sun's temperature and measure the solar wind and connect the two.
Scientists across Europe and ESA's partners around the world are now working to interpret the vast amount of information Solar Orbiter is sending back. And this is just the start of a mission that promises to transform our understanding of our nearest star.